Hello everyone. Hope you all are fine and doing well. I'm Poonam Sharma. Welcome you all another session of chemical reactions and equation chapter with you. In previous class we have already completed this chapter. And now in today's class I'll discuss question answers of this chapter, which is chemical reactions and equations. And if you have any doubt in any particular topic from this chapter, you can ask or write in the chat box. I'll take your doubt one by one. So let's begin with the question answer of this chapter. What type of questions can come in exam on the basis of the topics from this chapter? First question is, why does not silver evolve hydrogen on reacting with dilute sulfuric acid? Here, this is sulfuric acid. This is H2SO4. So the question is, if silver reacts with dilute sulfuric acid, no hydrogen gas is evolved. What's the reason? If you remember, I have discussed this reactivity series when I was explaining displacement reactions with you. I hope you people have revised your topics. If you haven't, so please revise it today. So that's why it's easy for you to understand these concepts. Sometimes you know the answer, but you don't know how to present your answer, how to frame your answers. So, how will you write? And one question can be asked in many ways in exam. So, don't get confused. Don't just mark up the question, don't learn answers. Just understand the concept and the reason behind it. So, that's why I'm explaining each and every question in detail. That's why it's easy for you to understand the question. Now the question is, why does not silver evolve hydrogen on reacting with dilute sulfuric acid? As you can see here, this is reactivity series. Children, you need to learn this reactivity series. And if you face any problem in learning it, there's a very easy way to learn it. How can you learn it? Please stop calling me a careless zebra. Instead, try learning how copper saved gold, platinum. Okay, so if you learn this, so you can easily learn this reactivity series. And the metals which are at the topmost position, it means they are highly reactive, and as we are moving down, the reactivity rate decreases. Okay, so here, this is the easy way to learn this reactivity series. Please stop calling me a careless zebra. Instead, try learning how copper saved gold, platinum. Because on the basis of this reactivity series, so many questions can come in exam. So you need to learn it. And this is the easy way to learn this reactivity. As you can see here, if you'll see this hydrogen. Hydrogen is placed here. And the metals which are above the hydrogen, it means they are more reactive than hydrogen. Okay. And the metals which are placed below hydrogen, it means they are less reactive than hydrogen. So if they are less reactive, so they cannot displace hydrogen. So here, just see the position of silver. Silver is placed below hydrogen. So if silver reacts with dilute sulfuric acid, it cannot displace hydrogen. As a result, hydrogen gas cannot evolve. I hope you understood this. If silver, this symbol of silver is Ag, if it reacts with H2SO4, with this dilute sulfuric acid, So it cannot displace hydrogen. Why? Because it is less reactive than hydrogen. And the metals which are less reactive, they cannot displace hydrogen. If in place of this silver, any other metal is present, for example potassium, suppose we have sodium with potassium, so it can easily displace, and the reaction will be like this. In this case, hydrogen gas is evolved. So I hope this question is clear to you. So the metals which are more reactive, they can displace hydrogen. Otherwise, the metals which are less reactive, they cannot displace. Okay? So I hope this question is clear. And I'm saying again, please learn this reactivity series so that you can easily solve questions like this if they'll come in exam. Next question is, what happens chemically when quicklime is added to water? Here, chemically means when these two chemicals, when they react with each other, so what will happen? The quicklime, the chemical name of quicklime is calcium oxide, and it can be represented by CaO, that is calcium oxide. And the common name is quicklime. This is common name and this is chemical name. So when this quicklime is added to water, a lot of heat is produced. Have you ever seen when laborers are doing construction, so they'll mix cement. So to make cement, they'll mix this quicklime with water, which results in the formation of slate lime. And when you touch that container in which they are mixing it, so it becomes very hot. When you touch it from outside, you will feel that temperature, you will feel that heat. So when calcium oxide, or we call it quicklime also, when we add it to water, a lot of heat is evolved and calcium hydroxide is formed with a hissing sound, somewhat like snake sound. So when these two react with each other, it results in the formation of slate lime. And what kind of reaction is this? Look here, this is calcium oxide. When it reacts with water, this is the formula of slate lime, or we call it calcium hydroxide. Plus heat is evolved. And just tell me one thing, if heat is evolved in any reaction, what do we call that reaction? Any idea? Yes, we call it exothermic reaction. This is exothermic reaction because in this reaction heat is evolved, and this is an example of one more kind of reaction. Do you have any idea? This is an example of, look here, there's two reactants. When they combine together, it results in the formation of one product. This type of reaction is combination reaction. So, this is a combination reaction as well as exothermic reaction. So, when calcium oxide reacts with water, heat is evolved. That's why it's known as exothermic reaction, and calcium hydroxide is formed. And this question can become in exam, why this reaction is known as combination reaction. So in this you have to write down the definition of combination reaction. Because you can write like this, because in this reaction, two reactants combine together, they result in the formation of product which is calcium hydroxide. Or another question can come, why this reaction, or why the reaction between quicklime and water to form slate lime is an exothermic reaction? And the answer is, now please tell me what's the answer for this question. Why we call it exothermic reaction? Yes, because heat is evolved. So that's why we call it exothermic reaction. So now just see, in one question, 3 different type of questions can be easily formed. So in exam, examiner can ask this one question in different ways. So you can write answer accordingly. Okay, I hope you understood this question. Or one more thing, in exam it's a 1 mark question. 1 mark question can also come. What's the chemical name of quicklime, or what's the formula of quicklime, or what's the chemical name of slate lime, or common name of calcium hydroxide. So you need to learn their chemical name as well as common name and their formula also. Okay, so I hope this question is clear. It's a very important question. Generally it comes in 2 marks, or it comes in 1 mark when it is asked in exam like this, why this reaction is known as exothermic reaction, or why we call it a combination reaction. So these are 1 mark questions. The next question, why a combustion reaction and oxidation reaction? First of all, you need to understand what is oxidation reaction. When I was explaining this chapter, I explained this oxidation reaction to you. There were 2 types of reactions, oxidation and reduction reaction. So why combustion is known as oxidation reaction? If you remember oxidation reaction, any idea what is oxidation reaction? What happens in case of oxidation reaction? There, I told you 3 things are there in oxidation reaction. Might be there is loss of electrons, addition of oxygen, or removal of hydrogen. Then if any of the case, that reaction is an oxidation reaction. And when we are talking about combustion reaction, see, in combustion reaction, combustion means here the burning process. And this combustion reaction takes place always in the presence of oxygen. If you remember in your junior classes, you people have studied about one activity, that oxygen is needed for combustion. That take 2 jars and then place one candle on each jar and put another jar over it, and one is then place do not place any jar on the another beaker in which you have placed the candle. So which one will get extinguished and which one keep burning? So which is not covered, that keeps burning, because for combustion oxygen is required. So combustion reaction takes place in the presence of oxygen. This was the activity. I think you people remember this activity. And then cover this with a jar and leave it open. Then this will get extinguished after a certain period of time, and then this keeps burning because it gets a supply of oxygen. So combustion is an oxidation reaction because when combustion takes place, it takes place in the presence of oxygen. It means we are adding oxygen to it. Okay? So here is an example of one such kind of combustion reaction. This is CH4, which is methane. When this methane gas burns in presence of oxygen, it produces carbon dioxide gas and water. So this is a combustion reaction. And why we call it? Here you can see we are adding oxygen to it. So it means addition of oxygen is an oxidation reaction. So that's why we call it oxidation reaction. Okay. Now next question. Why are food particles preferred packed in aluminium foil? See, we always pack our food in aluminium foil. What's the reason behind it? Why we are not packing our food material in any other metal? Because aluminium does not corrode in atmosphere. When this aluminium comes in contact with the oxygen, it will not corrode so easily. A protective coating of aluminium oxide is formed on the surface of the coil, and it stops any further reaction of the metal. This layer, this aluminium oxide layer, protects the aluminium to get corroded when it comes in contact with air and water. So that's the reason we keep our food in an aluminium foil, and it will not get spoiled for a longer period of time. But if we choose any other metal instead of aluminium, so if we are taking metal which is highly reactive in nature, so that can readily reacts with oxygen like iron. That's the reason why we are not keeping our food in iron utensils. Because when iron comes in contact with water and oxygen, what will happen? Any idea? Yes, when iron comes in contact with oxygen and water, it results in rusting. But this will not happen in case of aluminium. So that's the reason why we always keep our food particles or substances in an aluminium foil. So I hope these questions are clear to you, which I am discussing with you. If you have any query or any doubt, you can write in the chat box. Or this question can become like this. Why are food particles not preferred to be packed in iron container? Because iron can easily react with it, or iron get rusted easily. So that's the reason why we are not packing our food material in iron and in copper vessels. Okay. If you remember, I discussed that corrosion of copper and iron with you. Copper forms a green layer, this green layer covering over it. And iron also forms a brown layer covering. So that's why we are not keeping these food particles to be stored in iron and copper. So this question can come in this way also. Instead of giving aluminium, they can give iron or copper. Now next question. A substance X is used for coating iron articles is added to a blue solution of a reddish brown metal Y. Just see here, reddish brown metal. Reddish brown metal. Why? The color of the solution gets discharged. Identify X and Y and also the type of reaction. Now just understand question first of all. Here a substance X used for coating iron articles. So it means reddish brown metal. From this color, we can easily say that this Y is an iron. Okay. After seeing this hint, reddish brown. So it means it is a rusted one. Okay. And blue solution, the color of the solution, it means, and copper sulfate. The color of copper sulfate is blue, CuSO4. It's blue in color. So when iron immersed in copper solution, and we use copper sulfate, it's salt solution. So the color of that copper sulfate, which was blue earlier, it becomes discharged, it becomes colorless. So in this you have to identify. So here substance X is iron and this Y is copper. And when iron and copper reacts with each other, so it's a type of displacement reaction. I'll just show this reactivity series again. Iron and copper. As you can see here, iron is more reactive than copper. So it can easily displace it. So that's the reason why its color changes. Its color gets discharged. Because iron being more reactive than copper, it can easily displace it and takes up its place. So this reaction can be like this. Iron easily displaces copper and we'll get this one. It means we get iron sulfate. It displaces copper from its salt solution and copper is left behind. Okay, so this type of reaction occurs when iron reacts with copper. And because it displaces copper from its salt solution, that's why it's known as displacement reaction. Because it displaces, it removes copper from its place and takes up its place and becomes iron sulfate. I hope this question is clear to you. And next question is, a student burned a metal A found in the form of ribbon. The ribbon burned with a dazzling flame and a white powder B is formed, which is basic in nature. Identify A and B. Write the balanced chemical equation. When I was discussing combination reaction with you, there I have explained this example. When magnesium reacts with oxygen, magnesium occurs in a ribbon form. And if you remember, I discussed one more question with you related to this one. Because before burning, we need to clean that magnesium ribbon with a sandpaper to remove the layer of which one? Yes, magnesium oxide. To remove the layer of magnesium oxide so that magnesium can easily burn. Okay. So here question is, a student burned a metal A. Metal A is there. If that student is burning that metal A, which is present in a ribbon form, so in a very thin form. So when it burns, a dazzling flame and white powder is formed. A very shiny flame is produced. And if white powder B is formed, its nature is basic in nature. I'll discuss about acid, bases and salts in next chapter. So this is basic in nature. So we need to identify A and B. So A is because it's present in the ribbon form. So this X is magnesium. And when it reacts, when it burns, it forms magnesium oxide. Because just now I told you when combustion takes place, it always takes place in the presence of Oxygen. Yes. So when magnesium burns or combustion reaction takes place, it takes place in the presence of oxygen, and it results in the formation of magnesium oxide, which is basic in nature. And now tell me, student, whether this equation is balanced. Because the question is write the balanced chemical equation. So please tell me whether this is balanced or not. What do you think? It's balanced. Okay, just let's check it whether this equation is balanced or not. So by using which method? Yes, we are using hit and trial method. By using hit and trial method, we can see whether the reaction is balanced or not. And what is the first step? First write down reactants and then products. Then write down the name of the elements involved in a chemical reaction. And what are those elements? Here we have magnesium and oxygen. Any other element is there? No. So we have only two elements, that's magnesium and oxygen. On the product side also we have similar type of elements according to law of conservation of mass. That mass can neither be created nor be destroyed. It means number of molecules are same, and number of molecules are same on the reactant as well as on the product sides. So we need to balance it. Now let's see, if we look at reactant side, magnesium is 1 in number, but on product side it's 2 in number. And look at oxygen, it's 2 in number, and on the product side it's 2 in number. If you remember, I told you this subscript is representing number of atoms. It represents number of molecules. So this 2 is applicable to both for magnesium as well as oxygen. Now after writing this, we come on this conclusion that it is not a balanced one. Because according to a balanced chemical equation, what will happen in balanced chemical equation? Yes, the number of reactants are equal to number of products. But here they are different. It is not a balanced one. This is first step. Now second step is how to balance it. Oxygen is already balanced, so no need to balance this oxygen. Only we need to balance magnesium. So if I write 2 here, now just check whether this is balanced or not. Now on reactant side, magnesium is 2 in number, and now on product side, here also it's 2 in number. And oxygen is already balanced. Now this is a balanced chemical equation. So I hope this question is clear. And one more question can come. Okay, I'll ask one question to you first of all. I have written this equation. Can you please tell me what type of this reaction is this? Which type of reaction is this? Yes, it's again an example of combination reaction. Okay, because here again 2 reactants combine together to form one product. So it's an example of combination reaction. Now let's see. There are 3 questions in one. First is which type of reaction is this? Second, balance this chemical equation. And the third one is whether magnesium oxide is basic or acidic in nature. So it can be come in any ways. Or this can come like this also. It's 2-mark question, an extremely important question. So I hope this question is clear to you. Okay, now let's move on to the next question. And the next question is, oil and fat containing food items are flushed with nitrogen. Why? I told you when we were discussing, when I was explaining rancidity. Rancidity is a process in which when any food item which contains fat or oil comes in contact with oxygen, it gives foul odor. So this process is known as rancidity. It results in the spoiling of food. The food gets spoiled. So that process is known as rancidity. And this oil and fat containing food items flushed with nitrogen means filled with nitrogen. So why? What's the reason behind it? Why we are using nitrogen? As we know, nitrogen is an inert gas. Inert gas obtained. Okay. So this nitrogen gas being an inert in nature, when we fill it with the food item which contains oil and fat, it acts like a barrier which prevents that food to come in contact with the oxygen or air which contains water vapors and oxygen as well, and prevents oxidation. As a result, it prevents the spoilage of food material. So that's the reason why we use nitrogen gas in a food item which contains oil and fat. So I hope this is clear to everyone. And this nitrogen here acts like an antioxidant. Anti means it does not allow the food material to come in contact with the oxygen. It prevents oxidation, which prevents the spoilage of food. So that's the reason why we use this nitrogen gas. I hope this one is clear. And the next is balance the equation. How will you balance this chemical equation? Look here. This is HNO3, calcium hydroxide, calcium nitrate, and water. Now look at the compounds which are present and then see how can we balance it. Now if you look here on the reactant side and the product side, just have a look. This is nitric acid. Here it's 1. Okay. Now look here. If you'll see hydrogen. Hydrogen here is 1, but here is 2. Okay. Now here, this nitrate, here is 1. Okay. And here is 2. Calcium 1, calcium 1. And this OH, here is 1, here is 1. Okay. Now, here is 1 and here is 2 because it is applicable to both. Oxygen 3 and 2, 5. Okay. 3 and 2, 5. And here 6 and 7. Okay. So now how to balance it? If I write 2 here, so it becomes 2 3s are 6, 7, 8. 3 2s are 6, 7, 8. So on both the sides, oxygen is 8, hydrogen 2, 2, 4, and here 2 2s are 4. It's also balanced. And then comes to nitrogen. It's 2, and here is also 2. Okay. Now what's left? Calcium is left here. Here is 1, here is 1. Now you can see all elements are completely balanced. Now it's a balanced chemical equation. Just adding 2 here and 2 here, it becomes a balanced chemical equation. So I hope this is clear to everyone. How to balance this chemical equation? Look here. So what's the first step? According to the hit and trial method, first I have written all the elements which are involved in a chemical equation: hydrogen, nitrogen, calcium and oxygen. Okay. Then I have written reactant and product side, how many they are present in numbers. After writing this, then I come to know if these two numbers are different, it means it is not balanced. So first I'll balance the maximum, the element which is maximum in number. Do you remember that those rules or those steps? First write down name of elements, then write down the number of molecules present on both sides, then choose the element which is maximum in number. So here oxygen is maximum in number, so we need to balance oxygen first. Okay, so that's why I have balanced oxygen first, then hydrogen, then nitrogen and calcium. So in this manner, now our equation is completely a balanced chemical equation. And children, please do practice of balancing these chemical equations. The more you will practice, more you will learn. I hope these questions are clear to you. And if you are facing any problem in any of the question, you can ask in next class also. Because in next class, I'm going to discuss few more questions from this chapter and how to solve them. I'm giving you one task. Please balance 2 or 3 equations at least, so that you'll get an idea how to balance it. And these are the steps which I have already explained to you. So go through each and every question in detail. Thank you everyone. I hope these questions are clear. And thanks for your patience and enjoying this class. Thank you so much.